This is for Year 12 Specialist Maths. It comes out of 2F, Geometric Proofs of Vectors, and to question number 19. ABCD is a parallelogram. So here I've got my A, B, C and D. B to E and A to F is an extension of that line. And I know that BE distance equals AF distance, which equals BC distance. And because it's a parallelogram, that's also equal to that. If it's a parallelogram, I know they're parallel, and I know that they are parallel because it's been stated to be a parallelogram. Okay, in part A, I've got to prove that EX and FX meet at right angles. Therefore, if I can prove that EX dot FX is equal to 0, therefore the angle between them is 90 degrees if I can prove that. So I might call this vector A and this vector B, and EC dot FD, since EC is parallel to EX and FD is parallel to FX, therefore if this product equals 0, therefore that angle there must be 90 degrees. EC is the same as minus A plus B, because from E to C is going down there and across there, dot FD is A plus B, and that's going to be minus A dot A minus A dot B plus A dot B plus B dot B. The magnitude of A squared negative plus the magnitude of B squared, and since BE equals the magnitude of BC, therefore the magnitude of A equals the magnitude of B, therefore these are equal to each other, which is 0. Therefore it's 0, therefore the angle EXF is equal to 90 degrees because the dot product was equal to 0. So that's part A done. Part B says okay, in part B I'm told E to X is equal to lambda E to C. So E to X is equal to lambda E to C. So lambda must be a number bigger than 1 because E to X is longer than E to C. And f of x is equal to mu times f of d. So the same thing, mu must be bigger than 1 because you need to multiply vector fd by mu to get fx. And I know that the magnitude of AB is equal to k times the magnitude of BC, and BC is the same magnitude as BE and AF and AD. Okay, I'm going to put a line across here. I'm going to call that M. And I'm going to make M parallel to both BC and AD, so it's going to be a parallel line across there. And I'm going to consider the triangle which is EMX and the triangle which is EBC. This angle is the same and that angle is the same. And that's that angle there. This angle here, which is that angle there, is the same as this angle here, which is that angle there. And this angle are the same. So these two triangles are similar triangles. And I'm going to consider down the bottom, I'm going to consider MXF and the triangles FDA. And since this is parallel to this triangle and this triangle is also similar, because if I call that angle, that's that angle there and that angle there. These two angles are the same size, therefore that angle and that angle is the same. And this angle here and this angle here is both the same. Therefore these two triangles are similar triangles as well. Okay, I'd like to consider this triangle first. And what I'd like to say is that the corresponding side lengths are in the same ratio. Okay, so let me get some space. Okay, since I know that this is equal to that, this is equal to that, then this length must be equal to this length. And down here, since I know that this is equal to that, this length must be equal to this length. Since mx and mf is the same as mx and me, therefore me magnitude must equal mf magnitude, which means m is the midpoint of EF. So m is the midpoint. Now that was proven not by the fact that it looks like it's the midpoint, it was proven by these similar triangles and the fact that this side is equal to that side, because I'm told that up here. Since they're equal to each other, these are equal to each other. And since this is the same side as that, these two must also be equal to each other. So ME equals MF. Okay, now I'd like to set up my similar triangles. Okay, so what I know is here is my triangle, here is my known information. Because these two triangles are similar, therefore I can say that the magnitude of EC over the magnitude of EX should equal the magnitude of EB over the magnitude of EM. Okay, now E to M is 1/2 E to F, because M is the midpoint. So E to M is 1/2 E to B plus B to A plus A to F, and they're all magnitudes, which is 1/2 E to B magnitude is the same as A to F, so that's E to B as well. And B to A is 1/2, or K, B to C, and B to C is the same magnitude as E to B. So it's going to be 1/2 2 plus K EBs, and they're all magnitudes. So E to C over E to X E to X is lambda E to C equals E to B over E to M, and E to M is 1/2 2 plus K E to B's. That cancels with that, that cancels with that. 1 on lambda equals 1 on 1/2 2 plus K, which is 1 on lambda equals 2 on 2 plus K, therefore lambda equals 2 plus K on 2. So there's lambda in terms of K. Using similar triangles with my known information, I put one length over another length and I put my denominators in terms of the distance e to c, and the e to c is cancelled, and my other one in terms of e to b, and my e to b is cancelled, and then I rearrange this to give me this expression for lambda. Now I'll do mu. Okay, for this triangle down the bottom, the distance from m to x, the magnitude of mx, over the distance from a to d will equal the distance from x to f divided by f to d. Okay. M to x is the same distance as, hang on, sorry, I've just changed this to m to f over a to f. So m to f over a to f. M to f magnitude is the same as m to e magnitude, and e to b is the same as a to f. So this is going to be a half 2 plus k af all over af equals x to f is mu f to d over f to d. The f to d's cancel, the a to f's cancel, and I've got 2 plus k on 2 is equal to mu. So it's actually the same rule, and that doesn't surprise me. Part C then says, for this to be a rhombus, then what is the value of k? Now if this is a rhombus, then k is going to equal 1, because if this is a rhombus, the distance from A to B will equal the distance from B to C. So if a rhombus, k must equal 1. And since k equals 1, mu is going to equal 3 on 2, and lambda is going to equal 3 on 2 for it to be a rhombus. Okay, the last bit of number 19 asks about if the distance from e to x is equal to the distance from f to x, prove that that parallelogram is a rectangle. Okay, if it's a rectangle, since this is parallel to these two, this has to be a right angle for that to be a right angle, 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 and for that to be a right angle. So if I could prove that these were 90 degrees, therefore all of the other angles are 90 degrees because they're parallel lines, so therefore it's a rectangle. So what I'd like to do is, if e to the x equals f to the x, therefore ex squared should equal fx squared, which means ex dot ex has to equal fx dot fx. Now, e to the x equals e to the m plus m to the x, which means I have e to the m plus mx dot em plus mx, which means I have em dot em, which is em squared, plus 2em dot mx plus the magnitude of mx squared. And what's the other one? fx. fx equals fm plus mx, and that's going to be fm plus mx dot fm plus mx, which is the magnitude of fm squared, because it's fm dot fm, plus 2 fm dot mx plus mx magnitude squared. Since I've got an mx magnitude squared, they will add to 0. Em magnitude is e to m. F to m magnitude is the same distance, so they can cancel each other. I can divide both sides by 2, which gives me em dot mx equals fm dot mx. The dot product of em dot mx would be the magnitude of em times the magnitude of mx times the cosine of the angle, which goes from e to m to x, and that should equal the magnitude of fm times the magnitude of mx times the cosine of angle fmx. mx will cancel with mx magnitude. em is the same as fm, so they cancel each other. So if the cosine of angle EMX has to equal the cosine of angle FMX, EMX, FMX, I'm looking at these two angles, I'll highlight them. E to M to X and F to M to X, these are my two angles. Now, if one of these angles was bigger than 90 degrees, therefore its cosine will be negative, and the other one's cosine will be positive, so therefore their cosines will not be the same. So, since the two angles added together equals 180 degrees because they form a straight line, they both must be 90 degrees. Because if one of them was less than 90, that would make the cosine of the other one negative because it would be an obtuse angle. So since these are right angles, therefore ABCD is a rectangle.